Section 1.6 is about lines. Slope is defined as the steepness of the line. The way that we calculate slope is it is the change in y over the change in x. This delta, this triangle, means change. We have that slope formula that you've probably seen a lot of times, which is y2 minus y1 over x2 minus x1, which is, or where x1, y1 is one coordinate and x2, y2 is another coordinate. You can pick any two coordinates on the line and this will work. And you always simplify down to the same slope. When you have a vertical line, so if we have a vertical line, okay, let's say that this is at x equals a. So we have a point up here that's a2, and let's say a point here that's a0. So if we apply the slope formula, you end up with 2 minus 0 over a minus a, which is 2 over 0. We can never divide by 0, so this becomes undefined. That's why the slope of a vertical line is always considered undefined, or sometimes you'll hear no slope. For a horizontal line, if we have a horizontal line, let's say at b, y equals b, so you have a point here at 0b and a point out here at 3b. If you apply the slope formula, you have b minus b over 3 minus 0. So you end up with 0 divided by 3. 0 divided by anything is 0. So the horizontal line always has a slope of 0. Equation of a line, we have different types, different forms that we write it in. Your basic one that you've known forever and ever is y equals mx plus b, where m is your slope and b is your y-intercept. We try not to use this too much because it has very limited uses. It's nice to graph, but unless b is a very nice number, there's not much you can do with it. The other one is one that we use a lot more, which is y minus y1 is equal to m times x minus x1, slope, point slope form. So again, m is your slope. In this case, x1, y1 is any point on the graph. You can pick any point on the graph and this will work, this will hold. You and your neighbor could pick two different points and it would still be true, even though the actual equation would look differently. If you're using point slope form, which is a very useful form to use, just leave it. Don't try and simplify it down to slope intercept form. Just leave it in point slope form. This is 100% accurate unless it specifically asks you to solve for y or put it in slope intercept form. If it doesn't say that, just leave it in point slope form. The next is standard form. You don't see standard form a whole lot. It has very limited uses. Ax plus by is equal to c, where a, b, and c are all integers. Okay, this means that included in the set of, or are, and this bold-faced z means integers. There's not a whole lot of uses for standard form unless you're doing x and y intercepts. Otherwise, we don't really use it a whole lot. For a vertical line, if you have a vertical line, then if you're looking at this, let's say it's 2. No matter what your y coordinate is, your x value is always 2. So a vertical line is x equals whatever number that the vertical line is at. For a horizontal line, no matter what your x coordinate is, your y coordinate never changes. Your y coordinate's constant. So we have y equals a constant, and that's a horizontal line. So now what I want you to do is pause the video and find the equation of a line that goes through points 2, 3, and negative 4, 5. So if you find the slope, you should find that the slope is negative 1/3. It doesn't matter which point you pick to be first, as long as the corresponding y is over top of the corresponding x. So 5 has to be over top of negative 4, 3 has to be over top of positive 2. So you could switch these two, but both the numerator and the denominator should switch, and you should still end up with negative 1/3 when you simplify. So I'm given a point and a slope, so I'm going to use point slope form. I picked this first point, doesn't matter, I just picked it because it was first. So y minus the y coordinate is equal to the slope, x minus the x coordinate. This is exactly the same thing, or equivalent to, I guess I should say, if you would pick the second point, y minus 5 is equal to negative 1/3 x plus 4. X minus a negative 4 simplifies to x plus 4. Either of these are completely correct. Doesn't matter which one you leave your answer in. The next part is parallel and perpendicular lines. Parallel lines, you have a set of parallel lines. They have the same slope because they're increasing at the same rate or decreasing at the same rate, and they never intersect. Perpendicular lines have opposite reciprocal slopes. So if you have a set of perpendicular lines, they form a right angle. So remember, opposite reciprocal, positive becomes negative or negative becomes positive. Reciprocal means flip it over. So now I want you to pause the video and find the equation of the line that has an x-intercept of negative 3 and is perpendicular to this given line. So I simplified, or I solved for y in this given equation and got y equals 2x plus 14. Off of that, I could read that the slope of the given line is 2. But I want a line perpendicular to this given line, so I want the perpendicular slope. Opposite, positive becomes negative, reciprocal 2 becomes 1/2. So my new slope is negative 1/2. If I have an x-intercept of negative 3, that means my x-coordinate is negative 3 and my y-coordinate is 0. So I'm going to plug that in. I have a point and a slope, so I'm going to use point slope form of the line. Y minus my y-coordinate is equal to my slope, x minus my x-coordinate. You could simplify this and just say y, or you can leave it as y minus 0, it doesn't matter. X minus a negative 3 becomes x plus 3.